Hi, it's Mr. Baker here. Today we're going to be looking at Upthrust. Okay, so this is an animation of something called a Cartesian diver. It's like a little pipette or something like that, so a little bit of air inside here, and it's open at one end, closed at the other end, and normally it'll float, but when you squish the size of a bottle like this, then it starts to sink. So I'd like you to have a think, why do you think it does that? What's happening to make this sink when you squash the water in the bottle like that? Okay, so we've got a bottle full of water. We've got one of these divers which is sort of got some glass, some rubber and some air in it, and that's what this is. So this straw diver, or this diver here, contains an air bubble sealed inside. Without squeezing the bottle, when you're not squeezing it, the overall density of the diver is slightly lower than that of the water. So when you're not squeezing it, because you've got the air inside, it means that it will float because the density of this is less than the density of the water. When you squeeze the sides of the bottle, you increase the pressure on the air bubble. So you're squishing the sides, you're forcing the water up by increasing the pressure on the air, and so it's being squashed into a smaller space. So the air is taking up less space, so that decrease in volume of the bubble causes an increase in the overall density of the diver, and when that density becomes greater than the density of the water, it sinks. So releasing the pressure by releasing the bottle from your grip, unsquishing it, allows the air bubble to expand back to its normal size, and then the diver goes back up again. Okay, so that is how it works. So we can explain why things float and why things sink in terms of density, but we've also got to be able to explain it in terms of upthrust and the forces that are on an object, and that's what we're going to be looking at today specifically. So I'm going to try and explain upthrust. It's a word you probably have heard before when things are floating, and when an object is placed into water, what happens is it exerts an upward force on the object. So the water exerts a force upwards on the object, and that is called the upthrust. The water level rises as the object displaces water, so as you put something in water, the overall level of the water increases. As the volume of the object in the water increases, more water is displaced. So if you just had this poking out the top, not all of the volume of this would be displaced, but as I pushed it under, the whole volume of this object would be displaced by a certain amount of water, and the volume, the displaced water would increase in total volume up there. When the object is fully submersed, the volume of the water displaced equals the volume of the object. Right, so we've been looking at how pressure changes in a fluid, and because pressure increases with depth, the pressure of the water at the bottom of the cylinder is greater than that at the top. From this we can calculate the force, since pressure equals force divided by area. So there's a greater force upwards than downwards, and the difference between those forces is the upthrust. So because the pressure here is greater than the pressure here, because we've got more volume of water above this point than we have here, so the pressure difference is, this has got a greater pressure, so if we've got a greater pressure for the same area, it's going to have a greater force, so there's going to be an upthrust force pushing up, so the difference between those two is going to be this upthrust force. So just a statement here really, an object floats when its weight is equal to the upthrust, and an object sinks when the weight is greater than the upthrust. So hopefully a fairly obvious statement that we've made there. Okay, so having a look through these outcomes here, we've described what's meant by upthrust. We've described the relationship between upthrust and weight, and we have not calculated it, but we've looked at perhaps how we can, using the difference in pressure between the top of an object and the bottom of an object in a fluid. Okay, so that's this lesson on upthrust. Thanks very much. I'll see you next time.